Let's look at storage of iron. Okay, how is iron stored in our body? Now, I hope since you have watched the previous video on the iron deficiency anemias, both part 1 and part 2, you will have a better understanding of how the iron is stored. So, storage of iron is primarily in the form of ferritin, and then we have hemosiderin. Okay, we have the storage forms of iron in the form of ferritin and hemosiderin. Both are different. We'll discuss it in detail. What is ferritin? Ferritin is nothing but as it is a ubiquitous protein iron complex. It's a ubiquitous protein iron complex. And where is it found? Site. It is majorly found in, we'll go in the highest order, okay, in the highest levels, followed by the lowest. Based on the highest levels, the first site, as you guessed it right, it is the liver, followed by the spleen. Then we have the bone marrow, okay, and more than skeletal muscles. So this is the order. Highest levels are found in the liver, followed by spleen, bone marrow, and the skeletal muscles. And in the liver, where is it stored? It is stored in the parenchyma. Liver parenchymal cells, in the cytosol as well as the lysosomes. This is the basic animal cellular level. In the spleen and the bone marrow, it is stored inside macrophages. Why macrophages? Because they are the ones that are breaking down the RBCs by breakdown of RBCs. So macrophages, followed by skeletal muscles. Okay, this is how the ferritin is stored. Ferritin is the storage form of iron. It's a ubiquitous protein iron complex. It is found as highest level in the liver, in the parenchymal cells, cytosol, and the lysosomes, followed by spleen, bone marrow, and as well as skeletal muscles. Moving on to hemosiderin. Okay, hemosiderin. Let's look at what is hemosiderin. Hemosiderin is nothing but as a partially degraded protein shells, plus along with that partially degraded ferritin aggregates. So this is nothing but as a hemosiderin granules. Nothing but as a partially degraded protein shells along with the partially degraded ferritin aggregates. They coalesce to form hemosiderin granules. Now, in this hemosiderin granule, iron is chemically reactive. Now you'll ask me why iron is chemically reactive in hemosiderin complex and what happens. What happens is iron in hemosiderin, when exposed to potassium ferricyanide, it turns into blue-black stains. So iron in the hemosiderin, when exposed to potassium ferricyanide, it turns to blue-black stains, and this is the basis of Prussian blue stain. That is the importance of hemosiderin. Now, normally in a healthy human body, what are the normal iron stores? Majority the iron will be stored as ferritin, plus there might be some small trace amounts of hemosiderin. This is how the normal complex of iron stores in the human body, and these small trace of hemosiderin will also be there in the macrophages of bone marrow and spleen. Okay, this is the normal iron stores. Now what happens when the iron overload occurs? In iron overload, since the majority of normal iron stones were in the ferritin and small trace amounts of hemosiderin was present, whenever the iron overload occurs, that is iron in the body increases, the all of the iron overload is converted into hemosiderin. So this leads to hemosiderosis. What are the iron overload conditions? Hemochromatosis, then the beta thalassemia major. Okay, these are all the iron overload conditions. This leads to hemosiderosis, and this deposition will be seen in the liver, followed by pancreas, followed by heart and brain. Okay, these are all the complications of hemochromatosis, as you can see, and in further details of hemochromatosis we will have a separate video on that. So this is what happens in the iron overload conditions. Normally whatever iron we take, it will be mostly in the form of ferritin, and very small trace of hemosiderin will be there. And whenever there will be iron excess in case of iron overload conditions such as hemochromatosis or beta thalassemia major, it will lead to hemosiderosis, and the deposition will occur in the liver, pancreas, heart and the brain. Okay, now as I just told you, the normal serum ferritin levels were 120 micrograms per deciliter, and what happens in iron deficiency anemia, it will be less than 12 micrograms per deciliter, and in case of iron overload conditions, it will be as high as more than 5000 micrograms per deciliter. So this will be the serum ferritin level, serum iron level. Okay, this is about the iron. We have seen about its intake, about its transport, where is it stored, how is it stored, and what happens if it's excess or in less. Now moving on to the very important topic, that is the absorption of iron.